Hello friends, this is part 2 of a series I created about paddle dissections to explore some of the materials and technology used by paddle manufacturers and to investigate some of the recent issues affecting the legality of paddles, such as delamination. In the first part, we looked at how thermoformed paddles are made and how they differ from older technologies. And now we'll dive into how raw carbon fiber surfaces are made with peel-ply technology, and we'll try to figure out what's causing delamination. Peel-ply is a topic I've wanted to cover for a while now to clear up any misperceptions that my original video about spin loss on the Ben Johns Yola paddle may have caused. In that video, I looked at the surface of the paddle under a microscope and noticed significant wear on the texture. Under a microscope, the texture of this and every other raw carbon fiber paddle looked like a woven cloth and appeared to be a simple carbon fiber weave, which seemed to be a safe assumption given that they were advertised as raw carbon fiber. But I've since come to realize that what I was looking at under a microscope was actually not woven carbon fiber cloth. After talking with several engineers and paddle manufacturers, I learned that what we're looking at on the surface of raw carbon fiber and what we're calling raw carbon fiber is actually an impression of a fiber weave, leaving an embossed texture on the surface of the paddle. Many thanks to Dale at 60 and Dong at Rhombus for providing many insights into their paddle manufacturing process. And a big shout out to Nick Bichanich, who's doing some really cool stuff in the paddle industry that we'll all probably hear about soon. He left some very insightful comments on one of my videos, so I reached out to him. Nick had been doing paddle dissections of his own, and he inspired me to do the same, and we've been comparing notes ever since. As best as we can tell, most, if not all, raw carbon fiber paddles use a process that involves the use of a nylon or polyester fabric known as a peel-ply. That's pressed into a sheet of unidirectional carbon fibers and epoxy to create a texture. So instead of using carbon fiber filaments that are woven into a cloth, they're using carbon fiber filaments that are laid out unidirectionally within an epoxy matrix to create what is called raw carbon fiber. To be clear, the peel-ply fabric is removed, so there's no polyester or nylon left on the paddle face. The sheets of carbon fiber filaments and epoxy that they are layering and pressing a texture into are called pre-preg sheets, so they're pre-impregnated with epoxy. During the cure, elements from the uppermost pre-preg sheet seep into the gaps in the peel-ply, and when the peel-ply is removed, you're left with what looks like a woven cloth texture on the paddle surface. Honestly, it took me a while to be convinced that what I was looking at on raw carbon fiber paddles was an embossed texture and not actual fiber cloth. I mean, these peel-plies do a pretty amazing job of transferring a three-dimensional fiber weave pattern onto this matrix of carbon fiber filaments and epoxy, including the gaps between and under the strands in the weave. You can see from the cut profile of all the carbon fiber paddles I've dissected, including this 60 double black diamond, that there are 3 layers of carbon fiber, with the peel-ply embossed directly onto the top layer. These unidirectional pre-preg layers are oriented at 90 degrees from each other to increase the strength and stiffness of the finished product. I knew about peel-ply when I published my raw carbon fiber paddle guide back in March, but I still didn't know if peel-ply was used for every raw carbon fiber paddle. Now I can say with a fair amount of confidence that, at least up until very recently, every raw carbon fiber paddle used peel-ply. Selkirk might be doing something different with their 006 because they're advertising the use of 12K carbon fiber, which is very different from unidirectional pre-preg, but I still need to investigate. And the folks at Pickleball Apes are doing something different with their ProLine Energy paddle, which uses a hybrid carbon fiber Kevlar woven cloth on the surface, and then a peel-ply is applied over the top of this cloth using some type of epoxy or resin. So I do still stand by my claim that paddle manufacturers should be using premium carbon fiber brands instead of generic. As I mentioned in previous videos, I've seen a correlation between paddles that use Toray carbon fiber and the overall durability of the textured surface. In other words, the grit doesn't seem to wear down as quickly and the paddle retains its spin potential longer. Whether or not that correlation equates to causation is still unknown. In other words, is the surface texture durability on a paddle directly related to the use of Toray or other premium carbon fiber? There's just not enough data to say for sure. So does the quality of carbon fiber still matter? I would say yes, for sure. Maybe not as much as what I believed before when I thought that the surface texture was actually woven carbon fiber cloth. But as with anything, there's a greater probability that cheaper off-brand products will suffer from subpar quality control measures, resulting in performance issues, especially in such a high-tech industry such as carbon fiber composites, which are literally being used by NASA and SpaceX to blast things into space. And who knows, maybe the epoxy used in generic pre-preg carbon fiber sheets is cheaper than the premium options, which could also lead to quicker surface deterioration. So while the verdict is still out, I would still place more trust in a paddle manufacturer that spends a few extra dollars per paddle to use premium carbon fiber. On the other hand, the flip side of the issue is that Toray isn't everything. I do agree that it has become a bit of a buzzword lately, so let's not assume that every paddle that does not use Toray is garbage. Okay, this is the last topic I want to cover in this video. It was big news earlier this year when it became clear that early versions of thermoformed paddles were prone to suffer from what became widely known as delamination, which pushed paddles out of USAP legal specifications and caused them to be much more powerful. Pros started noticing funny sounds and way more power from affected thermoformed paddles, and the PPA started a program where if a paddle was challenged and it failed a deflection test, then the pro could lose their earnings and their wins would not be counted. So let's take a look at a broken thermoformed paddle and see what's happening on the inside. Very early in their production, the owners of 6-0 sent me one of their Black Diamond power paddles. This was my primary paddle for months with no issues until I started to notice all of the signs that it had become delaminated. It sounded weird when it hit the ball, its power noticeably increased, and the final nail in the coffin, it made that crunching noise when I pressed on the center. And when I say that this thing started hitting hard, I'm not exaggerating. Lately, I've been measuring serve speed on my paddles with a radar gun, and the Black Diamond topped the chart with the highest speeds. Its average came in above 60 miles an hour, which is even faster than all 5 EVA foam paddles I tested. To put that into perspective, EVA foam paddles are not tournament legal because they don't pass deflection tests and are way too powerful. It's important to note here that this problem is not unique to 6-0. It's affected the early versions of all thermoform paddles, and 6-0 has been one of the most active companies in finding a fix. Anyway, while delamination has become a catch-all term, there are actually 3 types of damage that can compromise a paddle to the extent that it will fail a deflection test. Number 1 being delamination itself, which is actually referring to the separation between the carbon fiber layers on the surface. Number 2 is disbonding, which is a separation of these surface materials from the polypropylene core. And lastly, number 3, core crushing, is when the polypropylene cells in the honeycomb core lose their stiffness and become soft and spongy. Here's the Black Diamond after cutting it in half. Before we get into the delamination issue, there are a few things to note about this paddle's construction. First, it was constructed with thermoforming, as you can see with the edge foam and carbon seam around the edge of the paddle, even through the handle. The surface material on the Black Diamond is called raw fiberglass. Even though this is fiberglass and not carbon fiber, it's created the same way, using 3 layers of pre-preg sheets and a peel ply to create that surface texture. The fiberglass layers aren't as easy to peel back as carbon fiber, but you can see here that it all looks very similar beneath the surface. They're using unidirectional pre-preg sheets layered at right angles from each other, and then embossing the texture with a peel ply. Okay, now on to the delamination issue. When you squeeze the cut profile with your fingers, it's very easy to compress the core. You can see the honeycomb cells buckling and they make that distinctive crackling sound. Compare this to the paddles that don't have this issue, like the double Black Diamond 14mm and the Rhombus R2.16. You can squeeze hard on these and there's almost no compression. Here's a close-up of the damaged Black Diamond pressing a metal rod into the broken paddle. You can see a lot of deflection on the surface as the honeycomb core bends and flexes. Compare this to the same amount of force applied to the unaffected paddle, where you see far less deflection and core crushing. So to the naked eye, what seems to be happening is core crushing. But when you take a look under a microscope, there's more going on. There doesn't appear to be any actual delamination. All of the layers of carbon fiber on the surface are staying together, but there is clear disbonding. When you pull on the surface layers with an X-Acto knife, it easily separates from the polymer core. Compare this to the undamaged double black diamond paddle, where the core is still firmly attached to the surface layers. So the problem seems to be that the core has lost all of its integrity. Its honeycomb cells have softened and lost their stiffness, and the core itself is separated from the facing material. Technically, this paddle is suffering from a crushed core and disbonding, but it's not delaminated, which is ironic considering that delamination is the most common word thrown around for this issue. And I would imagine that probably over 90% of delaminated paddles have the same issues as this black diamond. They're actually disbonded and have crushed cores. To me, true delamination seems unlikely and improbable. I can't think of many reasons why the pre-preg sheets would separate from one another short of bad epoxy or quality control issues where patches of the carbon filaments were not fully saturated with epoxy. Also, a separation of the carbon fiber layers probably wouldn't result in the increased power you see when the core gets soft and creates this trampoline effect. In fact, the opposite would probably be true with actual delamination, which would seem to result in power loss. Lastly, the crunching noise when pressing on the paddle face that most people use to diagnose delamination definitely comes from the core, not the surface layers. Anyway, this issue will probably continue to be called delamination because that's easier than disbonding or crushed core. In my opinion, the term crushed core is just unfortunate because any paddle put into a hot press during thermoforming is likely to have some compression of the core, as seen in this 14mm double black diamond. See how the edges of the honeycombs appear crushed compared to the completely vertical cells in the non-thermoformed rhombus. Yet, the core in the double black diamond is definitely not broken. It still retains its stiffness, and it doesn't compress and crackle when you squeeze it. I mean, I definitely think that it's possible that using too much heat and pressure in a hot mold would weaken the structure of the honeycomb cells, making them more susceptible to failure. And this is probably what happened in the early batches of thermoformed paddles before they realized that there was a problem. And it might be possible that this buckling in the core, like on this double black diamond, even if it shows no sign of softening or disbonding currently, could still be more susceptible to failure after prolonged use. But I still don't have enough data about this yet to say one way or another. Still, the term crushed core implies that a crushed appearance of the core indicates that it's broken, which is not the case. I much prefer Pickleball Will's term core eruption. But seriously, core corruption is a much better term and much more accurate because it could apply to both the softening of the core and its separation from the facing material. Okay, that's about all I want to cover for now. If you made it this far into the video, I really appreciate that you are just as much of a paddle nerd as I am. It makes me feel better. If any of the paddles discussed in this video strike your fancy, I have discount codes for most all of them in the description below. And stay tuned for more videos because I need to push through a backlog of paddle reviews. So coming soon will be reviews of the Bread and Butter Filth, the full 6-0 Diamond Series review, including the 14mm double black diamond, the full Carbon X Series review, and I'll be reviewing some new paddle companies that are experimenting with different materials, including the Cheetah Predion, which uses an aramid core, which I think has good potential for its better heat resistance than polypropylene. So it would be less likely to suffer from core corruption after being heat molded. Also, there's the Pickleball Apes Pro Line Energy Paddle, which uses a hybrid woven cloth of carbon fiber and Kevlar. I've been playing with that paddle for the past couple of weeks, and I really like it. So I'm excited to bring you all these reviews, and I'll see you in the next video.